All right, let's dive right in. Today, we're going to be detectives, digging into the past. And I mean that literally. We're talking about the stone record, the incredible story that fossils tell us about the history of life on Earth.
So think about this. It's like the ultimate cold case, right? The evidence is buried deep inside solid rock, all the witnesses are long gone, and the timeline, well, expands millions, sometimes even billions of years. So how on earth do we read a story that old? That's the mystery we're cracking today.
So here's how we're going to crack this case. First, we'll figure out what the clues even are. Then we'll meet the detectives on the case. We'll get into the nitty-gritty of how something becomes a fossil. Then we'll look at the forensic science, the crate mineral swap, and finally, we'll put it all together to read Earth's autobiography.
Okay, so first things first. Every good investigation starts with the evidence. Before we can figure out what it all means, we have to know what exactly is a fossil.
You know, the name itself actually gives us a huge clue. The word fossil comes straight from Latin, and it literally means to get something by digging. Which, yeah, pretty much sums it up, right? These incredible pieces of history are found because someone dug them up from the ground where they've been waiting.
Okay, so let's get the full definition here, because it's so much more than what you might think. See, a fossil isn't just some big dinosaur bone. It's any preserved trace of something that was once alive. That could be a bone, sure, or a shell, or even a footprint, but it can also be something way more delicate.
And this is a perfect way to think about it. Just picture it. A leaf falls onto some wet, soft mud. Then, over a long time, that mud hardens into rock. But guess what's trapped inside? That perfect outline of the leaf, every tiny vein and edge captured forever. That little ghost of a leaf, that's a fossil too.
All right, so we've got our clues. Now, who are the detectives? Let's meet the scientists who've dedicated their lives to solving these ancient mysteries. So the official name for this field of detective work is paleontology. You can think of paleontologists as the ultimate historians of the natural world. They're the ones reading a book that was written in stone, piecing together the epic story of life on our planet.
And of course, this field is huge, so it's broken down into specializations. On one hand, you've got paleobotany. These are the folks obsessed with ancient plants. We're talking everything from microscopic pollen grains all the way up to entire petrified forests. And then you've got paleozoology. This is probably what most of us think of, the animal side of things. Whether it's a tiny little shell from an ancient ocean or, yeah, a massive T-Rex bone.
Okay, but this brings up a huge question. How does any of this stuff, survive? How does it get preserved in the first place? Let me tell you, becoming a fossil is not easy. It is incredibly, incredibly rare. It's a journey against all odds.
And there's a word for this incredible journey: fossilization. It's this wild chain of events that has to happen just right to turn the remains of a living thing into a permanent record, etched right into the Earth's crust.
And the key word here is specific. A very, very specific set of things has to happen. Okay, so step one, obviously something dies. But here's the crucial part. It has to get buried and fast. We're talking covered by mud, sand, or volcanic ash, something that protects it from scavengers and just rotting away. And then comes the long wait. For thousands, even millions of years, more and more layers pile on top, creating immense pressure. And that pressure is what kicks off the final step, the transformation into stone.
And sometimes that quick burial happens in a totally different way, like with ice, which can lead to some absolutely unbelievable preservation. I mean, check this out. In Siberia, they found a woolly mammoth that was so perfectly frozen that its flesh was basically still intact after thousands of years. So well preserved, in fact, that the story goes the scientists who found it actually fed some of the ancient meat to their sled dogs. Wow! It just goes to show how important those conditions really are.
So that whole transformation step, that's where things get really interesting. Let's zoom in, way down to the molecular level. This is the real forensic science of how something like a bone actually turns into a rock.
Okay, so one of the main ways this happens is something called the replacement theory. And you can think of it like this. It's a super slow, super meticulous, one-for-one swap. As an original organic molecule dissolves away, a mineral molecule from the groundwater, like silica, slides right in and takes its place. One out, one in. Over and over again.
Now, the other way this can happen is through the infiltration theory. So in this version, it's less of a swap and more of an infiltration. Water that's just loaded with dissolved minerals seeps into all the little nooks and crannies inside a bone or a piece of wood. Then those minerals solidify, hardening the whole structure from the inside out.
So let's just put these two side by side to make it super clear. With replacement, you're getting a perfect mineral copy. The original is gone, but it's been replaced so perfectly that you get an exact replica in stone. Petrified wood is a classic example of this. But with infiltration, the original stuff is actually still there. It's just been reinforced, like filling a mold with concrete. So you have two totally different pads at the molecular level, but they both end up at the same place, a fossil.
Okay, so after all of that, this incredibly unlikely burial, millions of years of waiting, this great mineral swap, you gotta ask, what's the point? Why does any of this matter? I mean, what are these amazing clues from the past actually telling us?
Well, it's because every single fossil is a time capsule. It's a snapshot of a world that's long gone. Think about it. When paleontologists find a fish fossil in the middle of a dry desert, what does that tell you? It's proof. It's proof that a sea or a huge lake must have been right there. Or when they find a fossil of a tropical fern in Antarctica, it tells us that the climate there was once warm and lush. Fossils give us the hard evidence of evolution, of ancient ecosystems, of massive climate shifts. They are, without a doubt, the planet's ultimate storytellers.
You know, when you really think about it, every single fossil we find is like a word or a sentence, maybe even a whole chapter in Earth's autobiography. It's a story that's still being pieced together, still being discovered, one dig at a time. And that just leaves us with one really exciting question. What incredible chapter are we going to uncover next?